Hello, pre-algebra students. Mr. Lawrence here, and we're going to talk about scientific notation tonight. First of all, why do scientists use scientific notation? You're wondering what it is. You've probably seen numbers like this. Last year times 10 to some power, right? That's scientific notation. And we're going to be converting numbers from standard notation, the way you're used to seeing them, into scientific notation. But why are we going to do that? The reason is to deal with very large or very small numbers, like distances in space or the number of cells in the human body. That's what we do. Now, before we actually learn how to do it, because it's super duper easy, let's just talk for a minute about what happens when you take a number like 2 and you multiply it by 10. Well, I know you're all going to say, well, I know I get 20. Of course you are. But one thing you might not realize is that when you're multiplying by 10, the decimal point of the number actually moves. For example, 2, the decimal point is after the 2, right? And when you multiply by 10, it moves one place to the right. You fill in that little hole with a 0, and there you have 20. Works the same way if you take a number like, say, 3.61, 3 and 61 hundredths. If I multiply it by 10, well, that decimal point is going to move one place. How do I know one place? Well, let's see if you can figure that out. By the way, 3 and 61 hundredths becomes 36 tenths. Excuse me, 36 and 1/10, excuse me. What would happen if I took, say, 1.428 and multiplied it by 100? Well, that decimal point's not going to move one place. It's going to move two places. And notice, 1, 2, there's two zeros. That is not a coincidence. So my new number is 142 and 8 tenths. Okay, so scientific notation, we're actually going to be multiplying by powers of 10, multiples of 10. Okay, now one thing you need to know is, well, actually two things: where the decimal point is and where you want the decimal point to be. So where is the decimal? And where do we want it to be? Well, to be in scientific notation, we'll take the second question first. To be in scientific notation, we always want it after the first non-zero number. Okay, after the first non-zero number. So in problem number 1 here, sample problem number 1, we want the decimal point to be here. It's not there right now, but that's where we want it. In problem number 2, we want it to be after the 4, the first non-zero number. Problem number 3, we want it to be after the 1. In problem number 4, we're going to want it after the 2. In problem number 5, we want it after the 6. And in problem number 6, we want it after the 1. Okay? Now you may not realize this, but in scientific notation, your answer will always be between 1.00 and 9.99. Always between there, because if you went further, like to say 10.01, the decimal is not after the first non-zero number. So that would not be scientific notation. All right, Well, here's how easy this is, converting to scientific notation. I'm going to look at question number 1 is where is my decimal point? Well, when you don't see a decimal point, you assume it to be at the end, right? So in the blue problems, the decimal point is that black point at the end of the number. Now, in the red problems, you can see the decimal point is already identified. And here's what happens. I take this decimal point, and I have to move it to where I want it to be after the first non-zero number. 1, 2, 3, 4, 5, 6. So that's where the new decimal point is, and my number becomes 6 and 25 hundredths. But what I really did there is I divided this number. I divided by a multiple 10. I divided by, let's see, 1, 2, 3, 4, 5, 6, by 10 to the 6th power. So to make my number keep its same value without changing it, I have to multiply it by 10 to the 6th power. The 6 million number got smaller. I have to multiply it by a fairly large number. And 10 to the 6th means 10 times 10 times 10 times 10 times 10 times 10, which is a very large number. Let's try it on the 2. The decimal point's going to move 1, 2, 3 places. So my new decimal becomes 4 and 72 hundredths times 10 to the 3rd power. All I did was move it 3 places. That's where my exponent of 3 comes from. This one moves 6 places. I got an exponent of 6. All right, this one here, it looks like it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My decimal becomes 1/83 hundredths, and I'm going to multiply by 10 to the 10th power. Pretty simple, isn't it? Now, this one's a little bit different. I'm going to move the decimal point to the right. And notice my decimal number gets larger. In all the blue examples, the number was in the millions or thousands or billions, and it turned out to be a small decimal between 1 and 10, right? Well, in this case, the decimal was a small number, smaller than 1, and it got to be larger. Well, when I multiply by 10, I have to have a small version of 10. So I am actually going to use a negative first power. All right. Yeah, when I'm going from a tiny decimal to a larger number, my exponent will be negative. Well, check this out. Number 5. 1, 2, 3, 4, 5. My new decimal becomes 6 and 43 hundredths times 10. 1, 2, 3, 4, 5 to the negative 5th. How do I know it's negative? Because I know it started with a number smaller than 1, and my number became larger. To keep its value, I have to multiply by a negative exponent. Okay, so finally number 6. 1, 2, 3, 4, 5, 6, 7, 8. My new decimal is 1.41, and I'm going to multiply it by 10. And I'll also count 1, 2, 3, 4, 5, 6, 7, 8 to the negative 8th power. It's that simple. That's how you convert to scientific notation. All right, Mr. Lawrence signing off. Good night, everybody.